Hi everyone, and welcome to the second of 4 videos going through some past exam questions on ionisation energies. So this first question wants us to write an equation for the third ionisation energy of aluminium. So if it's the third ionisation energy, we've already done first ionisation energy and second ionisation energy. So that means the aluminium is already going to be Al2+, and it's going to be losing an electron to make Al3+. Okay. And we need to include the state symbols. Remember, the definition for ionisation energy is it has to be gaseous. Okay, then we have a graph here that it wants us to fill in, and it says on the axes add crosses to show the 13 successive ionisation energies of aluminium. Okay, we've already done the first one, we don't need to join the crosses up. Okay, fine. So for this, remember, the ionisation energies are always going to increase. It always gets more and more difficult to remove successive electrons. So we're going to see this going up, but it's not just going to go up in a straight line. We need to think about aluminium's electron configuration. Okay? And if we think about it just in GCSE kind of terms, if we've got 13 electrons, then you'd have 2 in the first shell, and then 8, and then 3, right? So that means it's always going to get more difficult to remove the electrons, but we're going to start with the outer electrons, right, and move closer to the nucleus. And the bit we need to show on the graph is that when we move to a new shell, it's suddenly going to become much more difficult to remove another electron because it's a whole shell closer to the nucleus. The radius has decreased a lot and the shielding will have decreased a lot as well. So it's going to be much more difficult. So we want to show these increasing, but we want to show big increases when we change a shell. So if this is the first one, the second one needs to be higher. The third one needs to be higher again. But then for the fourth one, we're going to a new shell. So we now want to show a big increase. So I'm going to go up here somewhere. Okay. Then we should have 8 that are all increasing, but increasing by small amounts. Okay. So we're going to increase a little bit. Do make sure these increase. Don't draw them in a horizontal line. Okay. They should still be increasing. So that's 4, 5, 6, 7, 8. And then the last 2, we should see another big increase again because we're going to another shell. So we'll go up here. And then a little bit of an increase again for the last one. Okay, so it shows the electron configuration 2, 8, 3. And of course it's backwards because we start at the outer electrons and work inwards when we're taking electrons away. Okay, then we've got a very similar question to one we've seen before. This question is about the attraction between particles. Okay, state how and explain why the attraction between the nuclei and the outermost electrons in gaseous atom. Well, okay, so they've just gone out of their way not to use the word ionization energy for some reason. The attraction between the nuclei and the outermost electrons in gaseous atoms, well, that's the ionization energy, essentially. How does that vary across a period? Okay, and so we've seen this question before. We know what things we need to talk about. So across a period, the nuclear charge increases. Okay, we get extra protons. Remember that the atomic radius decreases a bit because the electrons are being added to the same shell, but they get attracted a bit more by that extra charge. So nuclear charge increases, the atomic radius decreases, and shielding stays the same. The overall result is that, let's bring it back to the question, the attraction between the nuclei, and let's just copy that. The attraction between nuclei and outermost electrons increases. Okay, because again, attracted by the higher charge, and they're not as far away from the nucleus. Okay, we've got another couple of graphs here. So this is a nice easy one. It's just a 1-mark question each time, and it just wants to sketch the general trend. Okay, so we've just mentioned this, haven't we? That we've just said in the previous question, as you go across a period, then the attraction between the nuclei and the electrons increases. So therefore, the ionization energy is going to increase as you go across a period. So all we need to do is show that it's increasing. So we just draw a line going upwards. And that is literally as much detail as you need. Don't need to worry about what gradient it's at or anything like that, as long as it's increasing, because it's just the general trend. It's only 1 mark. So, and then we want to show the general trend in atomic radius, where I remember we said as you go across the period, the atomic radius decreases a bit. So we just need to show a line going downwards. Okay, that's nice and easy. Finally, last bit here. The successive ionization energies of aluminium are shown in the table below. Some of these ionizations involve the removal of an electron from an S subshell. State all the ionization numbers that involve the removal of an electron from S subshells. Okay, so for this we're going to need to write out the electron configuration of aluminium, right? So aluminium is going to be 1s2, 2s2, 2p6. Aluminium's got 13 electrons, hasn't it? We had aluminium. This question seems to have been about aluminium. We had 13 electrons here, didn't we? This is actually 2 separate questions, but you can see it's asking us about aluminium again for some reason. So, as I said, the more you practice these questions, the more similar ones come up. So we're looking for 13 electrons. So we've got 6, 7, 8, 9, 10. So 3s2 makes it 12, and then 3p1 makes it 13. So then if we're looking for the ionization numbers, then remember we need to be careful here. We're going to start, the first ionization energy is going to be this one, isn't it? We're going to start with the outer electrons and work in. So it won't be the first one, but it will be the second and the third for these two. And then we should have 6. So 1, 2, 3, 4, 5, 6. It won't be those. And then the next 2. And there would also be the 12th and the 13th, but they haven't asked us about those. Okay. So we want the 2nd, the 3rd, 10th, and the 11th. Those are the ones from the S subshells. And then write the equation that represents the 3rd ionization energy of aluminium. Oh, this is literally the same question, right? We literally did that like 5 minutes ago. The 3rd ionization of aluminium. So they really are lazy with the questions. Let's just put this in again. This is why it's really useful to practice questions like this, because exactly the same ones come up again. They're giving us 2 marks this time for some reason. Don't know why, but we'll take it.